Hello everyone, my name is Scott. I am the keynote speaker of the E79 group, and our group members include Nico and Jerry. Today, the main topic we are going to tell you about is energy stored in a capacitor. Before we start with this concept, let's first understand what a capacitor is. Capacitance is the ability of a capacitor to store charge, which is measured in farad. Capacitors are usually used in conjunction with other circuit compounds to produce a filter that allows some electrical impulses to pass while blocking others. Capacitors usually are made of two conductive plates and an insulator material in between them. When a capacitor is connected to a circuit, the positive pole of the voltage source begins to push electrons from the plate to which it is connected. These pushed electrons gather in the other plate of the capacitor, causing excessive electrons to be stored in the plate. Now I will tell you how the energy enters the capacitor. When we connect a battery across the two plates of a capacitor, the current charges the capacitor, leading to an accumulation of charges on upside plates of the capacitor. As charges accumulate, the potential difference gradually increases across the two plates while discharging. This potential difference can drive a current in the upside direction. To put it simply, when the charged capacitor is disconnected from a battery, its energy remains in the field in the space between its plates. The formula is C equal Q divided V. C is capacitance, Q is charge, V is electric potential energy between two plates. Then let's see how to calculate the energy stored in a capacitor. U equal UE times V equal UE times A times D. UE is the energy density. V is the volume of the area between two plates. A is the area of plates. D is the distance between two plates. Then UE equal 1/2 E times E squared. E equals V divided D. V in this formula means the electric potential between two plates. C equal Q divided V. Therefore, the energy stored with a capacitor can be expressed as UC equals 1/2 Clipping E squared times A times D equal 1/2 V squared times C equal 1/2 V times Q equal 1/2 Q squared divided C. This concept will also have many confusing places. Here are two more confusing problems for you, hoping to help you. The misconception one is an open circuit cannot function. The answer is, if it has a capacitor, it can be function. Capacitors behave like an infinite resistance in a circuit. The misconception two, when we discharge a capacitor, its potential energy increases linearly. The left figure indicates a charge and B indicates a discharge. According to the Kirchhoff's loop rule, which means when the capacitor is charged, the charge on two plates increases non-linear. According to the right charge time function, when time goes by, it grows to the upper limited amount of charge the capacitor can hold. Capacitors will also have many applications in life. We provide some examples. A defibrillator that is used to correct abnormal heart rhythm delivers a large charge in a short burst to a person's heart. Applying large shocks of electric current can stop the arrhythmia and allow the body's natural pacemaker to resume its normal rhythm. A defibrillator uses the energy stored in the capacitor, and some such as all this equipment, uninterruptible power supplies, camera flash, pulse laws such as magnetic coils, and lasers use the energy stored in the capacitor. Now it's about the question. The first question is an examination of an application of the capacitance formula. Consider the circuit below, for which the charge on the positive plate of capacitor 4 is 6.6 current, but its charge on the positive plate of capacitor 3, given the value above. We can see that C3 and C4 are in parallel, so the voltage across them is constant. From this, we can use the formula to calculate the answer. The step like this. The second question is a test question about the energy released by the capacitor. A capacitor is initially neutral. We hook it up to a battery until it reaches equilibrium and then disconnect the battery. We then hook the capacitor up to a light bulb. What happened to the light bulb? The answer is B. The bulb will illuminate when power is applied. If you remove power, the bulb illumination will decrease, then go out. Its illumination will fade off because the charged capacitor will supply current to the bulb as it discharges until it's depleted. How fast the capacitor discharges depends on the size of the capacitors and the resistance of the bulb. The above is the entire content of the final project of our A1719. Thanks for listening.